Hello everyone, welcome to today's webinar. This webinar is for all the ultrasonic testing experts who want to make sure that they have the best future-proof ultrasonic testing equipment. It's for people who want equipment with high accuracy, good signal quality, and also equipment that streamlines their processes and facilitates full traceability for their company and their clients. I'd like to start by introducing today's presenter. So we have Mr. Chris Udell from ProSec's headquarters in Switzerland. Chris is the product manager for ultrasonic testing. He has 20 years of experience as an NDT consultant in the nuclear industry, and then as a product manager in Switzerland. He's an expert in ultrasonic testing, including phased array ultrasonic testing and TOFT. He's also an expert in eddy current testing and automated inspection systems. The recording of today's webinar, including the presentation, will be made available to all attendees on demand. And if you have any questions after the webinar, you can contact us by email, and our email addresses will be shown in the final slide. So the webinar will start in a couple of minutes. It will take approximately half an hour, and then we will have a question and answer session. If you would like to ask any questions, please type them in the Q&A tab on Zoom, and we will answer them in due course. So for those of you just joining us, welcome once more. We have Chris Udell, our product manager from Switzerland, who will be speaking at today's webinar, and he will share the many unique features of ProSec's new flaw detector, ProSec UT8000. So without further ado, I will pass to Chris. Enjoy the webinar.
Thanks, Maria. Let me just share my screen. Okay, good morning from Switzerland. Happy to share with you today the webinar of the future of flaw detection using the ProSec UT8000. I'm Chris Udell. I'm the product manager for flaw detection at ProSec, a Screening Eagle company. Oops. So today we'll start by doing a brief introduction, look at the market of ultrasonics, especially with the current pandemic conditions and how that's been affected. Then we'll go into introducing our product and how we can help in solve some of the issues that's been caused. Then we'll look into the software, and then have a look at other items in our metal portfolio that can perhaps help you too as well. Then we'll go into about 10 minutes of questions and answers if you wish. So as an introduction, ultrasonic testing is used at all stages of production, all the way from initial raw material to on-site inspection and in-service inspections. We've seen during the pandemic that manufacturing has slowed down to almost a stop. And in China, it's now starting to ramp up again. And we'll see the same trend in the rest of the world too as well. Service inspections, except for the aerospace industry in oil and gas and power, have still been continuing as we're in this situation. The advantages of ultrasonic testing is that it's a volumetric method, and it's used to detect surface and subsurface defects and discontinuities. You can have good sizing and you have an instant result, no waiting back. You also have minimum part preparation, such as you don't need to prepare the surface as much as you would with dye penetrant, and it's not hazardous. You don't use dangerous chemicals or radiation. You can see in the charts at the side that the top one over here is the number of power plants around the world. There's around about 30,000 of them. There's hundreds of millions of kilometers of pipelines. And there's typically, not at the moment, but there will be soon, typically 20,000 flights a day, which all have critical defects in there that need to be detected. And if they're not, there could be some problem. So we estimate that even with this pandemic going on, there's 100,000 inspections per day. The corrosion won't stop if the pipelines and the power stations are still operating. So we still need to inspect things despite the whole world being in some form of lockdown. We believe as well that inspections should, in the future, there should be many more inspections. So this will help as well. So let's have a look at the evolution of equipment. Back in the 1950s and 60s, we had the analog system, you can see here. This required the detailed analysis of an A-scan by an operator. It was very simple to use. You had typically 3 controls for the gain, the range, and the delay. And the signal response rate was very quick. Then about the 1980s, early 90s, whole industry switched to digital flaw detectors. We did lose some kind of performance with that, but we got items such as gates, embedded DAC curves and wizards to set up, but we lost some signal performance, but it still required the detailed analysis of an A-scan by an expert operator. And now we can have a look at what's next. And when we have a look at what's next, we can see the current trends in other industries worldwide as well. So what we've noticed in the current pandemic situation is that remote access is super important. Now being able to view data and communicate across borders, across sites and locations is very important. We've seen companies now accelerating their digitalization strategies. If they've not already started, they've definitely started now. And that's actually shown that we can be just as efficient working from home as we are in the office as well, especially for meetings and other things like that. And we've seen that the digital divide has been widening. So those who have got digitalization in their strategy are now becoming much more differentiated for ones that aren't considering that as well. And we'll see those ones who don't consider digital to be important slowly fading down. So now we can introduce our response to this, the conventional ultrasonic ProSec UT8000. It's a future-proof digital flaw detector for the next generation of flaw detectors. We start by looking at the hardware. We have a lightweight aerospace alloy, which is also IP67 and drop proof, but we've still managed to keep the weight of the combined battery and the flaw detector at around about 600 grams. We've got LEMO connectors, so you can connect any probe that you currently have. And we have USB-C ports in there as well, so you can connect other devices. The main thing about this is that we have a Wi-Fi generator here, which sends the signal of your probe to a tablet device. So this helps you to be very modular in the way you set up. You can put the hardware in your backpack or on your belt, and then you can have just holding the tablet with you on there as well. The battery solution is AA batteries we're using. That clips on there with a sleek bayonet connection. We've chosen AA batteries because it makes it flight safe. So you can take spare batteries with you on a plane. And also, inspections are carried out in the middle of nowhere. So if you need a spare battery, you can go to pretty much any store. And for €10 or $10, you've got a spare battery pack. You just fill it in. That gives you about 5 hours of battery life. If you need more, you could connect through this USB-C port, a kind of off-the-shelf power bank, or even your mobile phone charger as well, which makes it very practical. You can use the battery solutions you already have to really help you out on there as well. So this wireless signal is sent to an iPad. It's the best tablet out there. There's a full range of different devices, which gives us the largest screen, the best quality resolution A-scan. If you are in a training school, you can use a big screen to promote. You can even use cast it up to a big television or projector. So then you can really show people what you're doing there as well. I personally like the iPad. It's a good balance between iPad mini. It's a good balance between screen size and weight. You've got 300 grams of weight from the iPad mini. And if you need extra storage space, you've got up to 1 terabyte storage space, which is kind of in line with the class leading phased array products. We have not compromised on specification, even though it's lightweight and small sized. We've got a 400 volt pulsar voltage in there. It's a true square wave. We can go up to 110 dB of gain. The signal to noise ratio we've got is excellent, so it allows us to use that full range. And the bandwidth, we can use from a 0.5 to 20 megahertz probe, which covers pretty much most of the applications. You can see here, here's an example of the excellent signal to noise. This is on a V2 block using a 70-degree probe. You can see even up to nearly 300 millimeters, you've got zero noise. This is because we've used the best in class low noise amplifiers. We've got the perfect square wave pulsar, so you can really get some excellent signals out of there, which helps you to resolve tips better, to inspect more difficult materials. We've benchmarked this against other systems, and it's class leading on the signal to noise. If we look at the hardware, what modes it can operate in, you can see it operates in pulse echo, both shear and longitudinal, so we have angle beam and straight beams. We can use dual pitch and catch, so we can have tandem probes or dual probes for corrosion mapping. And you can have through transmission as well for inspecting very attenuated materials. Also have a very unique grid mode as well. So this is when you're doing mapping of surfaces. Behind each of these squares, you can actually just swipe on the number and you'll get each A-scan behind that number, which gives excellent validation of the results. So a level 3 can check through the results and check through every A-scan. For example, if this is a blank one, you can swipe down on this square and then check if what the result actually was. We also provide a starter kit, including several probes, cable, couplant, and a small V2 block. Sorry, the other one was a V1 block. And we also can support you on any of your other probe needs. We have support from 2 of the leading probe manufacturers, GB Inspection and Sensor Networks. So if you have requirements from the European standards or American standards, we can help you out. And also they would help us out on any customization requirements you might have as well. The design of the Flaw detector is not just to look pretty as well, it has a function as well as the form. You can see we've got a magnetic screen holder here, which clips onto the board, the rail system onto the device. So you have an all-in-one device. So if you're on a factory bench or in a training school, you can check, you can have it as all-in-one device. Or if you're on site inspecting welds, like I've shown, I can put the screen exactly where I'm inspecting. So you're not looking down at the floor or away from where the inspection is taking place. And this really improves the ergonomics of the inspection. You can see that I can put the device right next to the probe. Now we can have a look at the software. We've got many experts in user experience, AR, and the like and workflow to really improve how we can do the setup and the analysis of an A scan. But actually, we didn't need to reinvent anything, because if you look here, we have used the simple gesture controls of a analog flaw detector. 3 simple controls, and you can control everything in the flaw detector just by swiping on the screen. Let me show you that again. So I can do a side swipe across to change the delay. I can pinch to zoom to change the range, and I can swipe up and down to change the gain. 1 full swipe down is 6 dB, or 1 full swipe up is 6 dB up. So really, it's very, very simple to use. So if you're doing any training, the user is not bogged down in kind of menus of how to select where is the gain, where is the delay. It's really direct access on the screen where they can do that. That's proved to be very popular with our users. Where the touchscreen is also very useful is on the setup as well. For example, if you're doing a DAC sensitivity calibration, what we can do is we can take the peak memory of the block, and then we just hit the peak, touch the peak on the screen, and then you've got your DAC in seconds. If you've made a correction, you just hit the red dot and redo it again. Or if you're recalibrating, you can correct the DAC very quickly. That's using a 0 degree on a back wall, but if you want to see it done in real life situations, here it is on an IOW block. We have a tester here, and what we're doing is we're getting the peak memory of each of the holes. We start the DAC wizard. He's going through. You notice he can use 2 hands to scan. He's not messing around with the gates to align them with the probe. The peak memory is recording exactly the maximum of the hole to align it. Three holes. Typically, this takes 1 or 2 hours to do normally. We're doing it here in a matter of minutes. We save typically on constructing a DAC around about 40 to 80%, depending on how many holes you're using there as well. You see, it's very easy to find the maximum with the peak memory. Just 2 more holes to go, and then we'll show you the wizard, how it's complete. Center one. Now he's ready. Didn't need to press record, but he's done that. So if we start the wizard, there we go, selecting the peaks in a matter of seconds. Done. We believe that's the quickest way to do a DAC curve on an IOW block. So now we can move on. This is where digitalization comes in. Data. We can get from the recordings of indications the real CSV output of the raw A scan. So you can take indications, recordings, and export them as CSV. You can add annotations. You can voice notes and pictures, just to really communicate that indication. Also, one of the key features of our device is what's known as the time rewind feature. Here's Tom, our expert in the US, to show you how it works.
Hi, I'd like to talk to you today about rewind time. Rewind time is a new feature in the ProSec UT8000 flaw detector. The ProSec UT8000 flaw detector can rewind time because it's constantly recording a loop of the previous seconds of the inspection. However many seconds is defined by the user, and that can be anywhere from 1 second to 10 seconds in time. So since it's constantly doing this, if we go over top of an indication and we can't reproduce it, we can hit record and still know that we've captured that peak. So to demonstrate this, I'll show you on a standard IIW type 2 block where we have a 2-inch radius and a 4-inch radius, and we'll use a regular shear wave transducer. So as I start the inspection, I go over and I go across my peak. Now you can see I can capture peaks with the peak memory, but sometimes duplicating that peak can be a little bit challenging. So if I just tap the record button, now I can go back into my review mode, and since we're recording the full data set, I can just go back through my full data set, just scrubbing and slowly seeing where is my signal going to match up with that peak indication. And there it is right there, or pretty close. Right there is the peak in gate 1. So if I go ahead and save that as a keyframe, now that'll show up in the reports. And I'll cover reports in a future episode. Meanwhile, thanks for watching and stay safe.
Thanks, Tom. That's the key, the rewind feature that we have in the Flaw detector, and that would be very useful for training operators remotely. You can send them files of echo dynamic responses from flaws that you're expected to find on site. Share the files that you find with experts, so you can really look and see if it's an actual defect or a false call as well. You can really show the echo dynamic response, not just a screen grab. In addition, we've also got an indication table. This is a great feature from phased array, which is missing on the conventional ultrasonic Flaw detectors, because reporting is just as important in manual UT as it is in phased array. You can see here that I can add an indication. So I'm going to get the peak of that, press record. When I hit go to review mode by pressing the gallery icon, I can double swipe down and I'm starting to build up a table where I can categorize my indications, and also it gives a location and size estimates on that based on the measurement toolbar. Here's again the second one. I maximize the peak, press record. I can view that in review mode, and then my table is updated with the new indication as well. The next part of traceability, another feature of digitalization is traceability. Here, it's a common in a lot of strategies to really understand what data was taken and how it was taken. And what we have is a feature called the logbook. We will have a look at, you can see, for example, all the measurement settings, if your device was in calibration, if you're where the measurements were taken, and a track of all the changes. So if the operator has been following procedure, you'll be able to see if they've changed the gain, if they've made the correct pulsar voltage and the like. The operator in turn can also add comments and voice notes and photos to this, so it gives a full report. So they can send photos, for example, if the scaffolding wasn't ready, or if the surface condition isn't correct. And that's also useful for your billable times. Through the cloud, our device is cloud connected, and we have a web interface there where you can instantly share the results. So not waiting back to go to the cabin to do a report, you can really instantly share them with your team or your supervisors. And there you get the full logbook and the results file instantly, at the moment that they're synced to the web. And this is quite important for the remote access, is that because it's an iPad, it's completely compatible with all the apps on the App Store. We've got Skype, we can use it through Zoom, as you saw, and as you saw with Tom, he was using it from TeamViewer. So what we can do is we can really share the data live with operators wherever they are in the world. So with travel restrictions and the like, and mobilizing experts to site, you can really save time and effort to really view that data. Just had a question on what's the price. Here we go. So what we do is for this Swiss quality, high performing ultrasonic hardware, we charge just 614 francs. We use a subscription model for the software where you pay less than 100 francs per month over 2 years. So to get started with the highest quality equipment in the market will cost you around about 3,000 francs, whatever that is converted to local currency. If you compare that to market offerings of around 8,000 francs, that's very good value, about 65% savings just to get started with it. And you can have the highest quality equipment for the price of a budget offering. Why have we chosen subscription? It's a regular payment made for products and services that's now everywhere in our daily life. You have easy access now to the advanced technologies at prices that you can only get a budget device. You can also look at the visibility of your budget, so you can have predictable costs. You're very flexible. If there is an oil and gas downturn or another pandemic, I hope not, but you can scale your business. You can either add devices or stop subscriptions once a year after that 2-year subscription. So you really have control of your devices. It has to be continuously innovated as well. If you see from Netflix, everyone would stop subscribing if they stopped providing new content. We have to be the same to keep you involved in this project. For example, if you look at the GPR project, we have experts in augmented reality to really show visualization of parts and the like better. And we work with Apple on some of these key features to really bring you the latest technology. If you're buying a flaw detector now, a traditional one, and keeping it for 7 years, you're buying very old technology. With the iPad, who knows what the iPad can do? We know that it has voice controls, maybe even augmented reality glasses coming very soon. I don't know what the future brings for 7 years, but it certainly can be very useful for flaw detection. So the Eagle subscription, please join us on the mission. We bring you the most advanced and powerful hardware with intuitive software developed by UX experts and experts from the field. We have the best mobile computing power with the iPad, and this brings together a great package. With the pricing, we can purchase the latest hardware, which in decades of ultrasonic flaw detection, the hardware specifications haven't changed much, so that's not going to change much. It's more on the software. You pay an annual fee, and you get access to this Eagle Cloud platform, which is supported by Amazon, very safe and secure. If you want to try, you can download, it's free. You can go onto the App Store and download it on the tablet. We've got some demo files there, but you can also reach out to your local expert to see, and they can share you some application data as well. So in conclusion, inspections are not going away. The shift to digitalization is happening right now, and we're here to support you on that. We put much effort into this, and we can't wait to show you. Fortunately, we couldn't show you in person, but we can request a demo. You can try and buy. We have a try and buy scheme in some areas, but please download the app and try it for yourself. It's not just the UT8000 that is in ProSec's portfolio. We also have an excellent phased array flaw detector. It starts off life as a conventional ultrasonic system with 2 channels, so you can run 2 probes at the same time. Useful if you're inspecting forging rings, for example. You can do the 45 and -45 at the same time. You can also upgrade it via code to TOF or phased array 1664. Already got all the recent, the most used sizing methods in there, so DAC, DGS, and AWS, and you can have it encoded, a 2-axis encoder with a B scan and a C scan. It works very well with a phased array wheel probe, and with that, it's IFT, which is also good for immersion testing as well. It has a web tool for preparation and reporting. That's one as well. So between the 2 items, we're covered all the way up to phased array from thickness to phased array. If you're doing welding testings as well, there's also our live UCI, which uses also a Apple iPhone to get the results via Bluetooth. You have super portability, and with previous UCI ultrasonic contact impedance testing methods, you had to buy 3 probes with 3 different test forces. Here we have a variable force sensor in there, so you can test all the different forces in one probe. You have the same logbook for traceability, and also flight safe batteries. That's our strategy. So you really have very flexible and practical ways of changing powering the device. You have, again, also the cloud storage of data, so you have that all together in the ProSec Cloud, as I showed before. And then our full portfolio is the EcoTip 550. This is the most versatile portable hardness tester available with 3 test instruments: the Lieb, which ProSec has invented, the UCI, and portable Rockwell. We have a touchscreen display unit, special view to display the weld hardness profile, and of course it's your Swiss precision and quality, especially in the software and hardware, so you can get reliable and repeatable results. We have worldwide support and expertise. You can see, we will share this with you, so you can contact your local expert directly. We don't have to go through a call center. We're approachable, and we're happy to answer your questions or any further information that you need. Okay, so that's the end of the presentation. We can open it up to questions and answers. I see some already coming in. If I stop sharing, I can hand back to Maria.
Yeah, hi Chris. I think we got a very good question from the Flaw. I think we can explain a little bit more on our grid mode features. Are we able to, explain a little bit more of its unique features compared to the other instruments out there?
Sorry, could you repeat that?
Yeah, it's regarding our grid mode, corrosion grid.
Yeah.
So can we explain a little bit more on how ours is compared to the other instruments out there, which has the similar functions?
Sure. Yeah. I mean, we can have a grid size of up to 10,000 spaces. So you can take 10,000 measurements, which is quite large. And of course, we've got the full data saved behind each of that grid, which is quite unique there as well. You don't just get a number or a screenshot. You can get the full data behind each of those cell recordings.
Yeah, and also I think our corrosion grid features, since it actually captures the raw data in full, users who actually capture the data can go back to the office and review the A scan. In the market, other instruments out there, once you capture the reading, you are not able to change the readings. But for us, we are able to review the readings from the A scan, and we are able to adjust the gate to go to the area where we actually miss, or rather when sometimes our threshold is not low enough, we miss out readings. So we can actually move the gate to capture the correct readings, or rather corrosion. Yep. And I think another one of the attendees is asking, what is the maximum time of our recording time?
So we have 10 seconds recording time. That's the full recording time. That's enough, we found, to get the full echo dynamic of an indication. Of course, if you don't need the data and you just want to do a screen recording, you can use the screen recording function on the iPad, and you can record as many hours as you want using the screen recording function. But the 10 seconds is real data.
Thank you. And another question is, when do you think that the Android application will release? Because right now we are only on iOS, so maybe you can explain a little bit more why we choose iOS instead of Android.
So yes, the reason for choosing iOS is that on the tablets, the iPad is the leading tablet you can get. It's the best around, and they have many different variants to suit the the requirements. If we had a Xiaomi or Samsung, it's very difficult to ensure that the data is correctly displayed and shown, because there's so many variants. With iPad, you have the whole, if it works on one, it will work on all of them. As well as Apple data is generally more secure than Android data as well. So we're thinking about security of your data.
Yeah, thank you. Is there any other questions from the floor? So another question, Chris, how light is our UT8000?
How light? So if you have it together with the batteries, it's around about 650 grams plus the iPad, depending on what casing you have for the iPad. If you have it in light mode with a small power bank, for example, the Flaw detector is around about 300 grams, so very light.
Yeah, I think that makes it light enough to fit on some of the drones in the market for remote control assessment inspections, right?
Yes, exactly. Yes, that's one market we're interested in as well.
Mm-hmm. And we have one question: are we gonna develop the unit to have a B-scan mode? B-scan function?
It is in the pipeline, yes. On the front panel, I didn't go into it, but there is a port for an encoder, a 2-axis encoder on there as well. So we're looking at, in the future, bringing to you B-scan and C-scan. If there's enough demand, maybe even taking some things from the GPR, like the augmented reality view, so you can show it.
Yeah. So the next question is a little bit more on sales. Is this product available in India, and what is the price?
It says Peter would like to answer this question live. Do we give him the sound?
Peter, maybe?
Yeah, this product is already available. As shown by Chris, the global pricing is 614 Swiss franc for the hardware, and for the software subscription per year.
Just less than 1,200.
Peter, are you still there?
Yes. You got my answers?
Yeah, I think so. The price for the Indian market is almost similar to the Swiss franc that we have shown earlier, right? It's just a bit currency conversion rate. Yeah. And the next question that we have is there an option for lifetime software instead of the subscription mode that Chris mentioned earlier? Chris?
There is an option for long-term subscription. We really believe in this subscription model of really freeing up your cash to use whatever you can. So if instead of spending 8,000 on a Flaw detector, you can spend 3,000, maybe grow your business by buying a hardness tester or even an eddy current machine or something like that. So you can really do that. But yes, there is options which we can contact you directly on as well.
Thank you. And we have another question on the types of probe, LEMO or BNC. I think the question is, maybe let me answer this way. Our UT8000 is actually with a connector of a LEMO 0 connectors. But the thing is, for your probe, whether it's a LEMO connector or a BNC connector, as long as you are using the correct cable to connect the main unit, which is the UT8000, to your probe, they are compatible and they should work.
Yeah, exactly. Yeah. Every probe we've tested is compatible so far.
So we have another question. What about calibration? Will it be software based? Chris?
The calibration is to the recent EN standard. It's fully compatible with that. It does that does mean that you have to hook it up to an oscilloscope, which doesn't allow for currently the software based. It's something we're looking into, but currently we can offer calibration services through this as well. Did that answer the question?
Yeah.
Yep.
Maybe we will take one last question from the floor.
What we should do is maybe share the... If you do have any other questions as well, please drop us an email.
Chris, there's a question about waterproofing. Do you want to mention the waterproof features?
It is IP67 tested and validated, so it can go underwater for 1 meter for about an hour, I think is the rules. So yes, it's fully waterproof. You can see from the design, we've got rubber caps on the connections and the like. Do we have difficulties while controlling the tablet with greasy fingers? We found that the iPad screen is very helpful in this because of the consumer market. They're trying to make it work with rain. So because we've got the gesture controls very large, like swiping up 6 dB gain, that we've managed to get around this. You're not doing fine movements with greasy hands. I think when you're calibrating and setting up, typically you're inside a cabin or on a bench where the greasy hands isn't so much of a problem. It's when you're out on the field, and that's where we found the main gestures you'd use were moving the gates, changing the gain and the range. And that's done very, very big gestures on the screen, which helps you when it's very greasy.
I think this is a very interesting question. I think we can answer this. How far is the connection? How far can we do the connection between the Wi-Fi and the main unit with the iPad?
So yes, we've done tests about 10 meters in length. If this is for a ROV use, we can also hook it up to a Wi-Fi range extender, and you get about 100 meters guaranteed with that, depending on the environment, if there's lots of piping and everything like that. But we've hooked it up to a range extender as well, so we can get very, very far.
Yeah, I think we also have some customers before who are very concerned about the lag that the Wi-Fi connection brings. We have actually done a lot of work and research and tests ourselves. So actually, the probe, the connection is actually very responsive. It's almost instant. So don't have to worry about the lag issue.
Mm-hmm. If Wi-Fi is a concern as well, we can also use the USB-C port and use the cable connection. That's an update coming very soon, so you can connect it direct with a long cable, and then you have, if Wi-Fi is restricted in the environment you're working in.
Thank you, Chris. I think we have answered most, if not all, of the questions. Thank you, everyone. We appreciate your time to join us with this webinar. I think if you have any questions, please look at the screen to find your nearest, our nearest colleague who can assist you further. If not, thank you. Bye-bye. Till then, till the next webinar.
Thank you.
Thank you. Thank you very much, everyone. Bye.
Thank you, Chris.